Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the angle sum of a polygon. So a polygon is a shape with many sides. It doesn't include something like a circle, which technically has no sides. So a triangle is a polygon with the smallest number of sides. It's any three-sided shape. Let's start by drawing a line that is parallel to the base of this triangle. So let's use what we learned in a previous lesson. So this angle here and this angle here are equal because they are alternate. So that's that Z shape I was talking about. So similarly, this angle here and this angle here, they are equal because of alternate angles, because we have some parallel lines. So let's call this final angle here Z. So this is a straight line. We know that the angle sum at any straight line is 180 degrees. This angle is 180 degrees. So that means x plus y plus z, those three made up an angle of a straight line, they must add to 180 degrees. That means x plus y plus z equals 180 degrees. We've just proved that the angles inside a triangle, the three angles, always add up to 180 degrees. Now this works for any triangle because you can perform this task on any triangle. You can always draw a line parallel to its base and go through the same logic. So we're going to use that the angle sum of any triangle is 180 degrees in order to find the angle sum of polygons with more than three sides. So let's have a look at that now. So here we have two polygons. A five-sided shape is called a pentagon, eight-sided shape is called an octagon. I'm going to find their angle sums using what I just learned about triangles. I'm going to divide them into triangles. So the vertex of each triangle must be a vertex of the pentagon. So I can't divide it into triangles like this, because then I'd be including angles like this that are not part of the pentagon. Can't do that. Instead, we're going to divide it up like this. See, each vertex of the triangle coincides with one of the vertex of the pentagon. I've divided the pentagon into three triangles. Each of these has angle sum 180. So the angle sum of the pentagon is just 3 times 180, 540 degrees. This works for any pentagon. We're going to do something similar for the octagon. We're going to divide it into triangles. So once again, the vertex of each triangle must coincide with a vertex of the octagon. So we've divided it into 1, 2, 3, 4, 5, 6 triangles. Each of those triangles has angle sum 180, so the angle sum of an octagon is just 6 times 180, which is 1080. So all of the 8 angles in octagon, they would all add up to 1080 degrees. So what about if the shape had a different number of sides? Well, if we let n be the number of sides that a polygon has, the number of triangles we can divide it into is n minus 2. For 5 sides, we had 3 triangles. For 8 sides, we had 6 triangles. If you had a 20-sided shape, you could divide it into 18 triangles. Now, each of these triangles has angle sum 180. So, I can just times that by 180, and that is the angle sum of any polygon. 180 times n minus 2, where n is the number of sides. So this will help us find unknown angles in polygons. So what we're going to do is we're going to find the value of x in each of these shapes. So first we have to figure out what the angle sum of the shape is. Well, this shape here has 6 sides. So its angle sum A is going to be 180 times 6 minus 2. So that is equal to 720 degrees. What I've just found is that the angle sum of any hexagon, that is any polygon with 6 sides, its angles inside, its internal angles will add to 720. Now if I add all of these angles up, I get 600 degrees. So x is just going to be 720 minus 600, leaving me 120 degrees. So let's look at this shape here. Well, this is a quadrilateral. It has 4 sides. You probably know that the angle sum of a quadrilateral is 360 degrees. It'd be 180 times 4 minus 2. Now, this is a special kind of quadrilateral called a kite. So in a kite, these two angles will be equal. So to find x, I have x plus this angle here will also be x, plus 65 plus 55, so that's 120, must equal 360. And we can just solve this equation from here. 2x equals 360 minus 120. X is just going to be 120 again. So 120 plus 120 plus 55 plus 65 gives you 360. How easy is that? Now for this last one, we're looking at what's called a regular polygon. A regular polygon has all of its sides equal. It turns out if all of the sides of a polygon are equal, then all its angles are equal. That's actually true if it's not a quadrilateral. So this polygon here has 10 sides. They are all equal. So that means each angle inside the polygon, I'll call it y, they will all be equal, and we can find them out easily. So the angle sum of a 10-sided shape is 180 times n is 10, 10 minus 2, which gives us 1,440. So if each angle is equal, a shape that has 10 sides has 10 angles. Each angle will be 1440 divided by 10, which is 144 degrees. So it's really easy to find the angles in a regular shape. So if y is 144 degrees, what would x be? Well, these two angles are at a point. You can see they make a full circle here. So that means that they add up to 360. Angles at a point add to 360. So x will just be 360 minus y, which gives us 216 degrees. How easy is that? Let's now look at finding the number of sides of a shape if we know its angle sum. So how many sides would a shape have if its angle sum is 2160? Well, we know that the angle sum of any shape is equal to 180 times n minus 2. If I'm told that the angle sum is 2160, I can form this equation and solve for n. N is the number of sides. So to solve this equation, I can expand the brackets or divide by 180. Either way works. So I'm going to divide each side first by 180. So here I get n minus 2 is 12. 2160 divided 180 is 12. This means that if the angle sum's 2160, I would be able to divide it into 12 triangles. So adding 2 to both sides, it would have 14 sides, which is a tetradecagon is its name. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.